Shaitanirrajim. Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Apex Grammar School contact address is Apex Grammar School 31G Gulberg, Lahore, Pakistan. Today's lecture, class 10, subject physics. Topic of today's lecture is 11.4, which is on page number 26, 27, and 29. We are doing chapter number 11 related to sound. Chapter number 11, we are doing pages. Today's we will cover 26, 27, and 24. Hopefully, we will do 11.5 and 11.6 article as well. Okay, you should be very prepared for this. Okay, so open your book, page number. I tell you now. This is the chapter we are doing. Like unit 11, sound. Next, the topic where we left, we did the numerical till numerical here. In my last lecture, we did till numerical. Today, we will do measuring speed of sound by echo method. This is on page number. Sorry, the page number is wrong. The page you should open the page 28 of your 10th class textbook. This is my mistake. In the slide I have written wrong. So sorry about that, and please open page 28 of 10th class textbook. I repeat, please open okay. The boys who have their cameras, please turn them on. Please turn boys, please turn your cameras on. Only boys, not girls. Only boys. Turn on your cameras. Thank you. So the page is on 28. You can see at the bottom. This is 28 page. I am doing of your 10th class textbook. Please open your textbook, page number 28. I am saying again and again. Please open page 28 of your 10th class textbook. Thank you. Measuring speed of a sound by echo method. We did last lecture, we did till here. So we did the numericals, but today's lecture, measuring speed of sound by echo method. How we can measure the speed by echo method. So the apparatus required, this is the activity you can perform by yourself at home. So apparatus required for this measuring tape, you need stopwatch, you need flat valve, there is a flat valve you need that can produce good echo. Procedure, use the tape to measure a distance of 50 meters from the wall. Stand 50 meters away from the wall and measure the distance from with the help of the measuring tape. Okay. Second step. Now clap your hands when you stand yourself at 50 meters away from the wall. Then Now clap your hands in front of the wall at a distance of 50 meters and check if you can clearly hear an echo. When you stand yourself 50 meters away from the wall, mark it with the measuring tape, right? When you stand 50 meters away from it, then clap your hands and uh, and check if you can hear the echo. The sound is coming back to you from the wall. Make sure the echo is not coming from any other wall in the area. You should make sure that there is no other wall. It is not coming. The sound is not coming from the other wall. It is only coming from the wall where you are standing 50 meters away from that wall. The time taken by the sound to travel 500 meters is the time difference between the clap and the echo. 100 meters is saying, why is saying 100 meters? Because when you sound, when you clap, it will hit on the wall, and it will take 50 meters. Uh, it will take 50 meters, and then when coming back, it will take 100 meters. Okay, so 50, 50, 100. 100 meters is the time difference between the clap and the echo. So now restart the clapping and start the stopwatch. At this time, step 3, you will do the perform this experiment. actually not restart the clapping and start the stopwatch. You must have a stopwatch in your hand. When you clap or when your sound, when your friends clap, one person take the stopwatch, another person stand, and when someone clap, you turn on the stopwatch. Okay, count the number of claps, the stop, the clapping, and the stop when you hear the echo of the 10th clap. Say. Now find the average time of the 10 clap. Why is taking the 10 claps? Because if you take one clap, it will not be a very perfect choice. But if you take a number of claps, okay, so each time you take the time, so when you take the average, you will get the accurate result. For instance, when we did the experiment of a simple pendulum, we take the 10 vibrations. Okay, 10 vibrations. We could take one vibration as well, but one vibration is not perfectly accurate. So we take the 10 vibrations and then we take the average and we get the accurate result. Similarly, you take the time for the 10 class and take the average and you will get the accurate time. Time. After calculating the time interval between the claps and the using formula S is equal to Vt. We can, you are familiar with this formula because we have read this in ninth class book. S is equal to Vt. We can calculate the speed of the sound. Since we know the V, we can calculate the V, speed of sound. How we calculate the flash of the, this is the numerical we are going to solve by using S is equal to Vt. Flash of lightning is speed is 1.5 seconds earlier than the thunder. How far away is the cloud in which the flash of has occurred? Speed of sound is 332 meters per second. You need to take V is equal to 332 seconds. You need to take V is equal to 332 meters per second, and the time is 1.5 seconds. Use this formula. The given data is time is equal to 1.5 seconds and velocity or speed is given to me, speed of sound is given to me, this is given 332 meter per second. So use this formula S is equal to Vt to calculate the distance. So S is equal to V, put the values V is equal to 1.5 and T is equal to V is equal to 332 or T is equal to 1.5. If you multiply, you will get the distance 498 meters. Okay, so this is the method we use, measuring of speed by echo method. How we can find the speed with the help of echo method? We perform the experiment. So the apparatus required in this measuring tape, stopwatch, and the wall where you are standing 50 meters. Okay. So we use this formula S is equal to Vt. We find the distance S is equal to Vt. You are very familiar with this formula as we have discussed in ninth class. Okay. The next topic is new topic is 11.5, which is also on page number 28. Open 10th class textbook page number 28. The topic is 11.5, noise pollution. We are going to start noise pollution. I read the first. We enjoy the programs on radio or television by hearing sounds of different quality. You have heard that when you hear the music, okay, you feel very pleasant. You feel very happy. But what happens if someone slam the door? If someone slam the door or do something which is the horn. If someone uh, uh, place the horn in front of you, you play the horn in front of you, what will happen? You will say him, okay, stop it, don't play it, okay. So the reason is some sounds are very create good effects on your ears, and some sounds create jarring or unpleasant effect on your ears. So if you watch the television program or radio television program, you feel very happy, you feel very comfortable, or you feel very pleasant. You are in a pleasant mood. But when happen when someone, your friend, your brother, slam the door, what will happen? You will say, okay, stop it, don't do this, don't slam the door. This is the two types of noise, right? Two types of sounds are there. The sounds which create very good effect on our ears are called the pleasant, uh, are called the pleasant sounds, or the like the sound of the piano, kind of sound of the flute. These creates a very good effect on our ears. That's why they are called the pleasant sounds. But what happened when uh, our ears are called musical sounds, right? However, some sounds produce unpleasant effects on our ears, such as sound of machinery, the slamming of door, the sound of traffic in a big cities. Sound which has jarring and unpleasant effect on your ear is called noise. This is the definition of the noise. Sound which create good effect on our ears are called musical sounds. So there are the two kinds of sound. One is called the musical sound, the sound which creates good effect, pleasant effect, or happy effect on our ears. Good effects on our ears are called musical sound, like the sound of the piano, flute, some music, songs being played. These are all called the musical sound. But on the other hand, if you talk about noise, sound which has jarring and unpleasant effects on our ears is called noise. Noise, I have told you, slamming of door, sound of traffic in a big city. These are all noise. Noise correspond to why they are called noise correspond to irregular and sudden vibration produced by the some sound. Like when someone is hammering on the floor, what happens? You say stop it because it is the irregular and sudden vibration produced by some sound. Okay. Noise. So noise is very dangerous. Noise is becoming very dangerous nowadays. Like noise pollution has become. This is also called any pollution is something which defect your ears, which defects your health, anything which harms your health, that is called the pollution. So noise is one kind of the pollution. We have so many types of pollution like noise pollution, air pollution, uh, these types of noise. But we are talking in this article, we are talking about noise pollution. Noise pollution has become a major issue of concern in big cities. In Lahore, for example, if you take the example of Lahore, so noise pollution is becoming a major issue nowadays because there are so many uh, uh, buses, buses, motorbikes. They are producing the noise because they are playing the horns in front of you. Uh, so these are called the noise. Noise is an undesirable sound that is harmful for health of human or other species. Transportation equipment and heavy machinery are the main sources of noise pollution. For example, noise of machinery, in industrial areas, loud vehicle horns, hooters, alarms, these are all kinds of noise. Noise have negative effects on human health and it can cause conditions such as hearing loss. Noise can give us a very negative effect on our health. What they do, they will create the aggression. You will, if someone is if you are living in such a place where all the times are cars are running or motorbikes are running, the noise produced by horns, hooters, what will happen, they will disturb your sleep, they will create a sleep disturbance, your mood will be aggressive, so hypertension, high stress, this is all caused by the noise. Noise can also cause accident by interfering with communication and warning signals. Noise can also cause accident by interfering with communication and warning signals. So if someone is playing the horns or in front of you and is disturbing you, if you are driving the car and someone is playing horns in front of you, you stop your car and you start abusing him. You know why? Because it creates unpleasant effects on your ears. It creates a jarring effect on your ears. You become disturbed. You become aggressive. This is just because of the noise. But if you if you talk about the safe limit of the level, what type of safe limit is required when you are working in some place, like if you are working in a factory where there are lots of machines are installed. What happened? You the engineers are working there, working on the machines. They try to reduce the noise level. what happen what happened they do, so countries like this, European countries, they, when the workers are working in the factories, they try to minimize the noise of the machines or these things, and they ask them to wear the uh, helm, ear protective equipment when working in the factory. They recommend them to wear ear protecting equipment before going or working in the factory. So the desirable working level or the noise level is 80 to 80 dB, 80 to 90 dB. The level of noise recommended in most countries is usually 85 to 90 dB over an 8 hours workday. If you are working in a factory 8 hours daily, then they recommend that the noise level should not be exceed 90 dB. So if you are working 85 to 90 dB, they are good for you. But if you are working more than this 90 dB, then it is not good for you. It is not good for your ears. You can lose hearing. Uh, Noise pollution can be reduced to acceptable level by replace the noise machinery with environmental friendly machinery and equipment. How can we reduce the noise? We can reduce the noise by uh, by replacing the machinery, noisy machinery, with environmental friendly machineries are those machineries which produce less noise, which are tuned every day, which are exercised every day, which don't produce any noise. So if you want to reduce your noise, you should replace the noisy machinery with the environmental friendly machinery and equipment. Putting sound reducing barriers or using hearing protection equipment. If you want to reduce the noise, you must, when you work in 8 hours in a factory or in any company where the machines are making noise, you must wear the ear protecting um, equipment before working into the factory or machinery. We talked about in this topic. We did study measuring speed of the sound of echo method. Then we studied noise pollution. There are the two kinds of pollution. We studied noise pollution. There are two kinds of sounds. One sound is very pleasant, which creates very pleasant effect, good effect on our ears. It is called musical sound, and the other sound which creates very bad effects on our ears. This is called noise. Noise. So noise, how the noise is produced? Noise can be produced by the machinery. They can be produced by someone is horning in front of you. Someone is playing slamming the door. These are all kind of the noise. But on the other hand, the musical sounds are those like the sound from the flute, sound from the piano, sound from the, they creates very good effect or pleasant effect on your ears. These are called the musical sound. So we talked about then how we can reduce the noise by when we are working in a factory, or how can we reduce the noise? We can reduce the noise by means of wearing the protective equipment when working in the factory. We must wear the ear protective equipment before working into 8 hours in the factory, and the recommended level of the noise is 80 to 90 dB in some countries. So if you exceed that limit, you for a long run you will lose your hearing. Okay. So now the next topic is 11.6. We are going to study now, which is importance of acoustics, uh, which is on page number 29. If you open the class 10 book, page number 29, you will find this importance of acoustics. The techniques or methods used to absorb undesirable sound by soft and porous surfaces is called acoustic protection. Okay. Now we are going to study the topic, new topic we have just started, 11.6, importance of acoustic. Okay. The definition of importance of acoustic is the techniques or method used to absorb undesirable sound by soft or porous surfaces is called acoustic protection. This is the definition of acoustic protection. So you will be very clear when we go ahead, such as porous materials. I read it for the techniques and method. Reflection of sound is more prominent if the surface is rigid and smooth, less if the surface is soft and irregular. Okay, the reflection of sound, reflection means reflect when they pass from the body, they will reflect. Then when they pass from one medium to another medium, this is coming from this way and it will reflect. It is reflecting. So this is the reflecting reflection. This is reflection. This is a phenomenal reflection. This is the surface. So when something strike on it, it will go back to the same medium again. This phenomenon is called reflection. Reflection, if if something is coming from this medium and it's going back to the other medium, so this is reflection phenomena. So diffraction, if something is passing through a slit or very small hole, this phenomenon is called diffraction. So uh, reflection of sound is more prominent if surface is rigid. Okay, I will try to explain. Sir is asking. Okay. At the end, I will explain you. Let me finish the topic first, and then I will explain you. Figure 28. I remember. Okay. Importance of acoustic: the techniques or method used to absorb undesirable sounds by soft and porous surfaces is called acoustic protection. Reflection of sound is more prominent if the surface is rigid. You can feel it, reflection very prominent, very vividly if the surface is rigid or smooth. But if the surface is not rigid, then you will not feel the less if the surface is soft and irregular. Okay. Now, such as draperies and rugs absorb large amount of sound energy and thus quiet echoes and softening noise. You know, in your home, when you in a room when you place the rugs or carpet, you know why you place the rugs and carpet, because there is less noise, because less noise produced. If you have a floor, then you have a more noise produced. But if something falls down on the uh, rug or carpet, you feel less noise. So it's mean absorb large amount of sound energy and thus quiet echoes and softening noise. In case of when you place the rugs or carpet in your house. Thus, by using such material in a noisy place, we can reduce the level of noise pollution. How can we reduce the noise pollution? By placing rugs or by placing the carpet in your room, you can reduce the noise pollution. This is the other way to reduce the noise pollution. However, if the surface of the classroom of public are too absorbent, the sound level may be low for the audience. However, if the surface of the classroom or public halls are too absorbent, the sound level may be low for the audience. Suppose you are in a conference, or you are in a hall, very big hall. So what they do in a big hall, so uh, when in a theater, when you go to the theater to watch the different program, they are performing live in front of you. Why the halls, they if the hall is too absorbent, the audience cannot hear the sound of the actors, right? So they make the sound such as like the hall should not be too absorbent. So I will explain you in a bit. Sometime when sound reflects from the walls, ceiling, and room of the floor, the reflecting surfaces are too reflective, and the sound becomes garbled. This is due to the multiple reflection called reverberation. In the design of the lecture hall, when they design the lecture hall, auditorium, or theater halls, they must a balance must be achieved between reverberation and absorption. It is not. It should not be too absorbent, or it should not be like this case. So many voices are coming from or echo is coming from. They want to make the voice clear of the actor or actress. They design the lecture hall or auditorium or theater in a in such a manner that they are not too reverberation or they are not too absorption. If they are too absorber, then the audience cannot hear the sound of the actor or actress. So they when they design the lecture hall or auditorium, they keep in mind that these halls and these halls or the theater or lecture halls are not too absorbent or reverberation. It is also advantageous to place reflective surfaces behind the stage to direct sound to the audience. So what sometimes they do, they if you ever go to the Alhambra, what they do, actors and actresses are playing or are performing lively, and the audience want to hear the sound of the actor and actress. Why? What they do? Sometimes they place the reflective surface behind the stage to direct the sound to the audience. They direct the voice of the actor and actress to the audience because audience want to hear the sound of actor and actress. That's why they make the reflective surfaces behind the stage to direct sound to the audience. This is the advantage how they make the voice clear to the audience. Generally, the ceiling of lecture halls, conference halls, and the theater halls are curved so that sound after reflection may reach all the corner of the hall. Sometimes curved sound boards are placed behind the stage so that sound after reflection distributed evenly across the hall. Sometimes what they do, ceiling of the lecture hall, when they design the lecture hall, conference hall, and theater halls, they make it curved. The reason behind it to make it curved, why they make it curved, they make it curved that sound after reflection may reach to the corner of the hall, so the audience can hear the voice easily. Sometimes curved sound boards are placed behind the stage, so the sound after reflection distributed evenly across the hall. Look, this place is curved. This place is made curved. Here soundboard is made curved. This place is made curved, so that when after reflection, the sound of the actor and actress goes to the audience evenly. It doesn't mean that someone is listening and someone is not listening. They want to distribute the sound of the hearing, a sound of the actor and actress evenly. So this is the end of our uh, importance of acoustic. We studied about importance of acoustic. Before this, we studied noise, musical sounds and noise. We studied and how can we reduce the noise and what effects creates on the health of women. Noise creates the health of women, and what is the level of the noise should be in when we work in a factory or what things create the noise and what does not create the what creates a good effect on our ears and what does not create the what does create the bad effect on our ears. Then we study the importance of acoustic. This is a technique or method used to absorb undesirable sound by soft and porous material is called acoustic. Then we discussed about how the lectures, halls, ceiling, uh, lecture halls, theaters, conference halls are placed, how they are designed. They are designed to keep in view that the audience can hear the voice of the actor and actress clearly, and they make it curved. Sometimes they make it curved So when the sound reflect back, they go evenly to the audience. The voice of the actor and actress goes evenly to the audience. It doesn't mean that someone is listening and someone is not listening. They want to make sure that voice goes to all parts of the hall evenly. Okay. The last thing is audible. Next is 11.7. We are going to discuss audible frequency range. This is very small topic. It is only two to three words are is there. So very this is the last topic for this lecture, today's lecture, and this is very small. Okay, we know that sound is produced by, this is the name of this topic is audible frequency range. This is on page number 30 of your 10th class textbook. If you open page number 30 of your 10th class textbook, this is audible frequency range. We know that the sound is produced by vibrating body. A normal human ear can hear a sound only if the frequency lies between 20 hertz to 20,000 hertz. If the then you know that the no, a human being cannot hear less than 20 hertz frequencies, less than 20 hertz and not more than 20,000 hertz. They can only hear the sound between these frequency lies between 20 hertz and 20,000 hertz, or we say 20 hertz and 20 kilohertz. Okay, 1000 means 20 kilohertz. You should remember the audible. This is called the audible range. This is called the range of frequencies which a human can hear is called the audible frequency range. And audible frequency range is 20 hertz for a human being is 20 hertz to 20,000 hertz. So in this look, if I read this in other words, a human ear neither hears the sound of frequency less than 20 hertz. They cannot hear the frequency. If the frequency is less than 20 hertz, they cannot hear it. If the frequency is more than 20,000 hertz, they cannot hear it as well. It also decreases with them. So different people have different range of audibility. So this level is called audible frequency range. So human ear can not listen less than 20 hertz and cannot listen more than 20 kilohertz. This is called audible frequency range. Okay, some people have different range because this is also depending upon the age. If you read this, it also decreases with the age. Young children can hear sound of 20,000 hertz, but old people cannot hear sound even above 15,000 hertz because due to the age, their hearing capability is going to be decreased. So they cannot hear, old people cannot hear more than 50,000 hertz. But young people can listen or 20,000 hertz or 20 kilohertz frequency range of 20 kilohertz. So this is called audible frequency range. So your homework for today is to memorize by heart the topic covered today and write down this topic once. Okay. What we discussed today, we discussed about we discussed the apparatus, and we discussed the experiment. Then we discussed noise pollution, and sound, musical sound and noise, and then we acoustic protection, and then audible frequency range. These are the topics we will cover today. Okay, the question is, uh, if you have any questions, please let me know. I read the question. Sir, please can you explain the figure